This is question 47 of Civil Engineering paper GATE 2016 afternoon session. A 3 meter wide rectangular channel carries a flow of 6 meter cube per second. The depth of flow at a section P is 0.5 meter. A flat topped hump is to be placed at the downstream of the section P. Assume negligible energy loss between section P and hump and consider G as 9.81 meter per second square. The maximum height of the hump which will not change the depth of flow at section P is. So in this question, for a 3 meter wide rectangular channel, the discharge is given, that is flow of that channel is given as 6 meter cube per second, and the depth of flow at a section is given as 0.5 meter. Now, downstream side of this section, a hump is placed, and considering negligible energy loss between this section and the hump, we need to find the maximum height of the hump which will not change the depth of the flow at section P. So this question is from the topic of hydraulic hump. You may study about hydraulic hump and how it is formed and what is the purpose to provide this hump. You may study all these things in detail by watching Module 5 Lecture 2 Flow over Hump and Channel Contraction Hydraulics by Dr. Arup Kumar Sharma, IIT Guwahati. So if we recall the about the hump, so the energy equation before and after the hump can be written. So E1 is the energy before the hump. So this will be equal to E1 plus the energy after the hump. So as per this figure, it may be seen the total energy is E2 plus del Z. E2 plus del Z, and this del Z is the nothing but the height of the hump, and this we need to find. So first find this E1. So E1 can be calculated by simple equation. Total energy is depth Y1 plus V1 square by 2G. So Y1 is given, that is flow at this section is given as 0.5 meter. Now we do not have the direct value of velocity, but we have the value of discharge. So if we divide the area with discharge, then we can simply find this velocity. So we can write the V equal to Q by area. So Q in this question, Q is given as 6 meter cube per second. So 6 meter cube per second, and area will be total width of the channel, which is 3 meter. So 3 meter into depth at that section. So depth is 0.5 meter. So this is 0.5 meter. So 6 by this 3, 2, and 2 by 0.4, this will be 4 meter per second. Now we can find this E1. So Y1 depth is 0.5 plus V1, just we got 4 square by 2 into G, that is 9.81 meter per second square. So after calculation, we will get the E1 value as 1.315 meter. Now E2 value. So E2 value here, the E2 value can be found in the form of critical depth of the flow, YC, and we know there is a relationship between YC and discharge. So first, just we know the relationship between the energy and critical depth, which is 3 by 2 YC, and we know this YC is equal to nothing but the Q, that is discharge per unit width, Q square by G to the power 1 by 3. So here discharge per unit width is, discharge is given as 6 meter and total width is 3 meter. So we can write discharge per unit width 6 by 3 a square divided by G, that is 9.81 to the power 1 by 3. So after calculation, we will get YC as 0.7415 meter. Now put this value here. So 3 by 2 into 0.7415. So after calculation, we will get E2 as 1.112 meter. Now we got the value of E1 and we got the value of E2. Now substituting this E1 and E2 value in this equation, so E1 is 1.315 is equal to E2 is 1.112 plus del Z, that is height of the hump we need to find. So del Z we got, after calculation we will get del Z as 0.203 meter. So here for this question we got the maximum height of the hump which will not change the depth of the flow at section P is 0.203 meter. So 0.203 is the correct answer for this question. Thank you.